All right, so these are also ionic formulas. And in some cases, I say they're more advanced because they are certainly more intimidating than the other ones. You see Roman numerals and other fancy words. But in some ways, they're actually easier because you don't really have to figure out the charges. They're usually given to you. So if you look at this first one, we have what's called iron 2 chloride. And the reason for that Roman numeral is if you remember earlier when we looked at the periodic table, and we had this middle section, which we kind of ignored. And the reason we ignored that is those atoms can form multiple charges much of the time. So for example, iron here can form a couple different charges. It can form a +2 charge, it can form a +3 charge. And we don't really know which it is until we see the formula. So if I just said iron chloride, you would have no idea which charge to use. But because it says iron 2 chloride, we know that the iron being used must have a +2 charge. So you actually didn't have to do much work there. Whereas if it said sodium, you'd actually have to figure out the charge. Here it says iron 2, so the charge is 2, and that's really it. Now chloride, we got to treat the same way. It's chlorine, so it's Cl minus 1. We have to look at the table and figure that out. All right, next we have lead, and it says lead 4 sulfate. So we have Pb 4 plus. And you might be saying, wait a minute, I thought lead always was 4. It's in this area with the column. And lead's kind of a weird one. Even though you would normally think it's +4, and it usually is, it can also form a +2 charge. So it's sort of one of our exceptions, but the Roman numeral will give it away and tell us which it is. Then we come across this sulfate. And you might say, oh, okay, that's sulfur. But it's not, because if you remember regular ionic formulas, like chlorine here, they end in "ide," iron chloride. So if this was lead 4 sulfide, it would just be plain old sulfur. But because this ends in something other than "ide," it ends in 8, it's something different. And that's called a polyatomic ion. And that is, on a chart, SO4 -2. That means that sulfur and 4 oxygen atoms combined to make the -2 charge. They need all 5 to do it. And so how do we know when we have a polyatomic ion? Typically, it just doesn't end in "ide. It ends in 8 or something else. The big exception to this is hydroxide. You'll see that that is OH with a -1 charge. That and cyanide are really the only two I can think of that end in "ide" that are still polyatomic ions. So these are the common ones you need to know. These are what are on the MCAS if you plan to take that. But otherwise, so you may have to remember these, you may not, really depends on your class, but these are some common ones that we use, these polyatomic ions. So going back, sulfate is SO4 -2. This 4 just refers to how many oxygen atoms there are. It does not have anything to do with the charge. Treat it like it's a letter. Don't even think of it as a number. All right, next, ammonium. You might be looking forever on the periodic table saying, where is ammonium? Well, it's not on the periodic table. It's a polyatomic ion. It's NH4+. So I'm going to write NH4+. And that plus means +1. It doesn't mean 4+. The 4, since it's a lower 4, it's a subscript, tells you how many hydrogens this is. Carbonate, once again, ends in 8. It's CO3 -2. So carbonate CO3 2-. All right, lastly, copper 2. So what's the charge on copper 2? +2. By the way, the first atom or first name is always the positive one, if you've noticed that. So iron is positive, lead's positive, ammonium is positive. So that might help you in this process. Hydroxide. This is one of those rare ones that end in "ide, but are actually a polyatomic ion. It's OH-, and again, we can confirm that on this chart. Hydroxide is OH-. It's not just a regular atom. So that's the first step. And it's no different after this. We look at the charges and see if they balance. So Fe is +2, chlorine's -1. Got to balance that. So this is going to be FeCl2. All right, next, lead and sulfate. So lead is +4. Sulfate's -2. We need more sulfate. So you have to add the entire sulfate, SO4 2- over again. So I've got 1 Pb. And then I'm going to show that there's 2 SO4s. And the appropriate way to do this is you write SO4, and then you put the entire thing in parentheses. and put a 2 outside it. It's just like in math. This 2 means double everything inside it. PbSO4, 2. You may be tempted to write PbS2O8, and while that technically tells you the number of atoms, it's not wrong in the sense of number of atoms, it's not really the right convention for an ionic formula. So don't do that. Use the parentheses, PbSO4, 2. All right, next, ammonium carbonate. We've got a +1 charge versus a -2 charge. So I need another NH4 plus. Again, remember, this 4 was not a charge. This 4 was part of the H. The charge is +1. So I need 2 NH4s. So NH4 I put in parentheses, 2. And there's only one CO3. So I'm just going to leave CO3 as it is. You might be tempted to put parentheses around it. There's no reason to because there's only one. So don't put parentheses around it unless you're planning on putting a number outside it. So NH4, I need the parentheses because I have to double it. CO3, no parentheses, leave it as is. All right, lastly, I've got copper hydroxide. So copper is +2, hydroxide is -1. So I need another OH. So I've got one Cu, and I have 2 OHs. And this is one that tricks a lot of people. If I just write OH2, that 2 is only referring to the hydrogen at the moment. I need to show there are 2 complete OHs. So even though there's no number like there was with NH4, SO4, I do need to put the OH in parentheses because that then says everything inside here gets doubled. There's 2 O's and there's 2 H's. So one way to figure this out is if you have more than one capital letter, you need parentheses. So OH, you need parentheses. But something like, well, I guess there's no example here, but if I have Na2S, I don't need parentheses around the Na because there's only one atom there. It's one capital letter. More than one capital letter, you need to have parentheses if you're going to have more than one. So that is ionic formulas. That's pretty much as complicated as they get. So yeah, do some practice with them, but be comfortable. This is not much different than what we've already done. So until next time, I am Derek Genova. Have a delightful day.